Okay? That's my unaided. That's my aided, right? The difference between these is gain. That's my insertion gain. Okay? This is response is my real year aided response. And my real year aided response has an output. If I go to the table, it'll tell me. My REUG is here. My REIG is here. That's the amount of gain that I'm giving. That's different. Okay. I'm now going to go into, I don't like looking at it this way. This is just me, guys. Sorry. Going to go here, 65 dB. You'll notice it says 70-something dB of gain. That's how much output. That's my REAR. That's my value for it. Okay, so there's my gain there for 65 dB. And at 80 dB, which is here, and you have to use this thing. Okay, I get that response. You will not have the response in this order because your 80 dB is going to be at the bottom, your 65 is going to be in the middle, and your 50 is going to be on the top. The reason I'm getting this gain is because what? This is a linear system. There's no compression here whatsoever. Okay? And then you can actually see where you're meeting target and where you're not meeting target. Now, we'll talk a lot about this in class tomorrow, and the question is should you meet target? The answer is yes and no. This target is only a prescription. It's not necessarily what the patient wants or what they like, but it's a starting point. So if you don't meet target, it doesn't mean it's a bad fit. So if the patient says to you the hearing aid is very, very tinny, and you decide just to reduce the compression ratio in the highs, the patient says it's comfortable, then that's what they want. That's what they like. That doesn't mean it's a bad fit. So use target as a relative term to help guide where you need to go so that you're not over amplifying. Okay? It's not an absolute. A lot of clinicians believe that this is an absolute, and it's not. Okay? So that's the second piece of this. That's pretty simple. The first two things go together. Do you see that? This shouldn't take you more than 10 minutes. Okay? And if I'm not mistaken, you're just doing one ear. You're just doing one ear. Okay? So that's pretty simple. And then what I want you to do is I want you to write this in clinical terms. So you're going to go in and you're going to say, I tested Clayton's open ear canal, and the peak resonance was between A and B, and it's this level. It's between this and this level. We put a hearing aid in. This is the model. This is the serial number. And at 50 dB input, this is the response we get. You can just bullet this out. 65 dB, this is the response we got. And at 80 dB, this is the response that we got. You would then take this and cut it out. And you put it in the chart. Okay? So now everybody knows what you used. And use pink noise. Use pink noise, because if you use a pure tone, what happens? Standing waves. Okay? So that's it. That's what that first piece is. It shouldn't take you more than, if I had to guess, 20 minutes to do that. And I'm being liberal here. Okay? The last thing that you have to do is actually a 2cc coupler piece. And what we're going to do here is a little bit more complicated. What we're doing now is we are correcting for the difference between the 2cc coupler that the manufacturer has and the person's ear canal. When you go into the fitting software, you will now enter this data, and it will either increase the gain or it will decrease the gain. Okay? Depending on what it is that you're trying to do. So, I need, there should be a bag here. Here it is. That is not it. That is not it. The EAR plug in your ear, and what's the measurement, so they'll put sound in it, the sound will be measured when it comes back out. and it will then compare that test to the test of the 2cc coupler that's here. And it will subtract or add those differences, and that is called the real ear coupler difference. I need that piece. The internal capabilities of a hearing aid electroacoustically, take the battery out. So a patient comes in and says, my battery's intermittent, okay? Or my battery doesn't last a very long time. You put one of these into the battery pill, put it in the hearing aid, run the device, and it will tell you whether or not the circuit of the hearing aid is working like it's supposed to. So that then allows you to do what we call a conformity test of the circuit, and then that then will tell you whether or not you need to send the hearing aid in. If it's working, then what's wrong? Patient has what bad? Batteries. And what Radio Shack does every year, at least they used to in North Texas, is in May, Better Speech and Hearing Month, all the hearing aids that have been sitting on their shelf for ages get sold for 50 cents a packet. And of the packets of the hearing aid batteries people buy, and they usually buy $15 of these, none of them work. And they're not refundable, which I think is a crime. But anyway, so you can test that for them. But here, it says RECD, which is here. Okay. So this is where you're going to put the EAR plug. You're going to put this in your ear. Okay, and we'll walk through this. And then we need to put this die on. So let's go here, and it'll tell us. So far this is good. You get this piece, right? Mm-hmm. Okay. So I'm going to right click. I'm going to go to tests. I'm going to go to on ear measures, and I'm going to go to RECD. Okay, it's right there. Okay, and it's going to tell me measure the coupler. So I click it, and I have to calibrate this. So to calibrate the coupler, I have a lot of noise in here. Oh, that's my fault. That's Teleco. Sorry. It's got to go in this little square. Okay. Don't do what I just did. Don't do the T. The T is Teleco. Let's try this again. And some of that may be this fan noise. Some of it is us clanging around here.
Turn the fan off.
Turn the fan off if you don't mind. That didn't really help any. But anyway, again, this is to let the loudspeaker be. You can turn it back on.
Okay.
Okay. So I went ahead and did it. Okay. So we went ahead and calibrated it. And so now it's asking us, do we doing this for an adult or a child? Right? We're going to do this for an adult. And so now what we do is we say we want to measure the coupler, and it says plug the RECD coupler into the appropriately labeled plug. That's this. Then I'm going to take this guy, and I'm going to couple it. And then I'm going to take this guy, and I'm going to plug this in here. The only difference again is your ear is going to replace this. Okay, so now I can just set this in here. I'm going to lock this down, and I'm going to hit continue. Continue. Okay, so it's measured the coupler. Okay, and now I'm going to measure the real ear. So now the difference is I just pull this guy out. Do we have any EAR plugs in here?
Yeah. Usually leave them all in the booth.
Would one of you mind grabbing one, and I'll do this on myself? That's a pretty cool little contraption. Now open up. Make sure you let it open. And I'll hit continue. Okay. So here's what you get. So this is the coupler. This is my ear. This is the difference between the coupler and my ear. And this is the average. Okay. And you'll notice, for whatever reason, you'll notice that the HA2 coupler is minus 34. What this means is the coupler is 34 dB louder than my ear. Okay?
And that's just because of resonance.
And I'm wondering if this isn't torn. I can't see this, but this looks like it's torn. Take a look at that. Do you see the same thing? Or is it just my eyes? This thing is eventually come up. There should be another one of these. Let's try this again. Let's try this again. Because it's not supposed to be that off. But basically, it's the coupler minus the real ear. Now, if it's a negative number, the coupler is louder, the real ear is softer. What's it going to do to gain? You're going to decrease gain, right? If it's the other way around, where your ear is louder than the coupler, what happens? So if you have a positive number, what happens? Then you're going to reduce the amount of gain that somebody needs. And that's all that is. That's the difference.
So if it's a negative number, you increase.
If it's a positive number, you decrease. It's the opposite. Okay?
Right, because the negative number is just saying that the coupler was louder than what your
the ear.
is.
Right. We try this again. Did that even change?
It went up from 17 to 18 at 250.
What's the standard? Like what?
Here's the standard down here. 3, 4, 6, 8, 7, 7, 8, 13, 13.
Oh, okay. So,
Okay.
but we're getting negative 34.
Yeah, and I'll figure out what this is, and it may have just been the way that we remember we calibrated it, and it was all goofy. And it may just be that we have another one of these next door, so I'll bring you that one. But basically, that's your lab, and then what you're going to do is you're going to tell me if the number's negative, going to increase gain. If the number's positive, you're going to reduce gain,
Yeah.
and that's going to happen with your prescriptive formula. So this is another correction factor. Okay, and that's it. If you see kiddos, you have to do the RECD. If you see an adult female, you have to do the RECD because the 2cc coupler is based on an adult male. Here's the question: should you do the RECD on an adult male? Why?
Because the 2cc coupler is from like the 1950s, 18-year-old men.
Right.
So not every male's going to have that.
Well, let's just take these three gentlemen here, okay? All same age, okay, roughly. And are all three of their ear canals exactly the same?
No.
Even though they're males?
No.
No. Okay, if I had to bet money, you've got the smallest ear canals and you've got the largest ear canals just because of mass. The other thing that we're probably going to find is that if you've had scarring of the eardrum, so have you ever had, any of you had middle ear infections? You've had it.
Tons.
Okay, so if you've had it, what's going to happen to the high frequencies? We now have stiffness, so what's going to happen to the high frequencies? They're going to go. All of that will now be included in your fitting formula because we now have to have the hearing aid work harder to overcome the gain that's your ear canal. If you do this on every single fitting, your patients are going to be more happy. Okay? That's it. This should not take you very long to do. That's what this lab is. And I cut out a lot of stuff. But this will give you the basics so that when you go to Arkansas Children's or you go to the otolaryngology clinic or you go wherever, this should be available to you. And I'll go pull this from next door because we've got to have a cable that works.
Cool.
Otro más? Got it?
Got it.
Come get me.